Let's have a look at Edx M2 June 2011 question 6 on the topic of general motion. Here's the question. Go ahead, pause the video and have a good read of it. What we're told is that the acceleration at time t is given by t minus 4. So acceleration in terms of t. And we're also told the initial condition is that when t is 0, v is 6. So we've got to find v in terms of t for part A. So let's write down the acceleration. Acceleration is dv by dt. Let's do it in blue. dv by dt is t minus 4. We want to find v, so I'll use the space at the bottom now. Integrating that then, v is the integral of t minus 4 dt, which is t squared over 2 minus 4t plus a constant c. Now, when t equals 0, we're told that v equals 6. Therefore, the constant equals 6. So now we know that v equals t squared over 2 minus 4t plus 6. And that's the first part of the question done. That's part A done. Now for part B, from part A we've got v equals, let's just check, what was it, t squared over 2 minus 4t plus c plus 6. And we want the values of t when p is instantaneously at rest. That means v equals 0. So put that equal to 0, we got a quadratic to solve. T squared minus 8t plus 12 equals 0. That factorizes nicely. So we've got it's t equals 2 or t equals 6. Those are the two times at which p is instantaneously at rest. 2 seconds or 6 seconds. One last part to do then, to find the distance between the 2 points when it's instantaneously at rest. Well, writing v down again, we've got v equals t squared over 2 minus 4t plus 6. And we know that we're concerned with the time from t equals 2 to t equals 6. That's the 2 times that it was at rest, and we want the distance travelled between those times. Now v is ds by dt, the rate of change of displacement. So s equals the integral of v. So we've got t cubed over 6 minus 2t squared plus 6t. But now stop and think, do we want to put a plus c in here, or can we integrate between limits? Now, but because we know that we want the distance covered from t equals 2 to t equals 6, the most straightforward way of doing this bit is to integrate between t equals 2 and t equals 6. Like that. And that gives us an alternative way instead of finding the plus c. Okay, putting those limits in, I'll leave you to check that this works out properly. The top limit is 0 and the bottom limit is 16 over 3. So it gives a value of minus 16 over 3. That just indicates a negative displacement. The actual distance is just 16 over 3, 5 1/3. And that's the last bit done for 4 marks. So putting the marks from the mark scheme in, for the first part of the question, there was a method mark and an accuracy mark for writing down dv by dt and integrating it to get that general expression with a plus c in. And there was another method and accuracy mark for working out v and finding the constant. For part 2, for putting v equals 0 and then solving the quadratic, there was a method mark there, a method mark there, and an accuracy mark for getting the right values of t. And then for the last part, the distance between the points, there was a method mark for saying that the distance covered is the integral of v dt. There was an accuracy mark for evaluating the right integral, and then another method and accuracy mark for putting the limits in correctly and getting the correct answer. So that was the 4 marks for that last part. Okay, thank you for listening, and here's some details about the Further Maths Support Programme.